All right, welcome back everybody. This is Mr. Mace and I'm here today to go over Unit 7, Lesson 4 with you. That should start on page 405 in your Math Expressions book. We again are kind of building off some prior knowledge. You should see that our learning target obviously for today is to learn a new skill called cross multiplication, or how we can use cross multiplication to help us solve proportion problems. We're also going to connect this strategy to something that we already know how to do, and that is solving factor puzzles. Okay, so you should see a lot of familiar things on this page, and this first question, this first screen here is simply connecting, telling us the why this process works, why this situation would work, taking it from factor puzzles to our cross multiplication method. All right. So you can see up here that we've got two equivalent fractions. We know they're equivalent, they tell us they're equivalent, and we've got all the numbers there, so we don't need to find any missing pieces. Now, they don't look like they're equivalent. If we think about what we would normally teach you to find if something is equivalent, can I get from numerator to numerator by multiplying a whole number? As an example, 1/2 is equivalent to 2/4 because I can multiply both the numerator and the denominator by 2. And have the numbers be the same. But what you're going to find out here through this process is that sometimes you can have equivalent fractions that don't necessarily look equivalent, because you could be multiplying them by a mixed number, or you could be multiplying them by a decimal number as we move forward here. And that's what we're trying to connect to what we know. And what we've worked on for a ton of the year, guys. If you're really being honest, we've seen factor puzzles come up multiple times. We've seen proportions, rate tables, ratios, all those kinds of things have come together for us so that we are kind of working to this algebraic concept, which is what cross multiplication is really trying to get us to do. It's trying to be able to solve a factor puzzle or solve a proportion problem without having to use a factor puzzle. We're kind of trying to cut out that middleman. We're showing you how we can use that to set up an equation, an algebraic equation with a variable, and solve for that variable and have it be a true statement. So what you're looking at here is a completed factor puzzle. And again, they're showing you the 5 and 9, 2 and a 3 are the factors that are on the outside of this. And you can see then the second step, as the arrow is drawing this over here for us, you can see that the second step is to not put the product inside the boxes, but it's actually breaking apart those products into their actual factors. And the reason we're doing that is we're showing you why this works, why cross multiplication is something that we can do to help us solve these problems. And we talked about the properties of multiplication, how you can manipulate those numbers and multiply them in any order, as long as the operations are all the same. As long as it's all multiplication, does it matter if I multiply 2 by 9 first or 2 times 5 first? No, it doesn't, as long as all of the factors or all the pieces of that problem are the same. All right, so if I look here, I'm following the blue line down from the upper left-hand corner down to the lower right-hand corner, and you can see that that is the multiplication of the factors involved on that side. And the opposite then is true if I start in the upper right-hand corner and follow the green arrow down to the lower left-hand corner. These are the factors that I am dealing with there. Now what I want to point out to you is, again, these are all stating that they are equal to one another. The equal sign is right there, and we're going to show you why that is. Okay, I've got 1, 2 on this side, I've got a 2 on this side. I've got a 9 on this side, I've got a 9 on this side. Now notice they're not in the same order. I'm not multiplying them by the same other factor, but as long as they are on those sides, it doesn't matter which order I multiply these things in, as long as the operation stays the same and the numbers and the factors stay the same. So here is my 3 for this side, here is my 3 for this side, and here is my 5 and my 5. So we know this is in balance. We know these two equations, or two sides of the equation, are in balance. Now we can put those things together and we can realize that we're coming right back to our factor puzzle, right? 2 times 9 is 18, 3 times 5 is 15, 2 times 5 is 10, 3 times 9 is 27, and we can trace these right back to our factor puzzle. Now, the other thing we can do is we can, like I said, bypass the whole factor puzzle process by also realizing that I can just go right from the proportion, or right from, in this case, the two equivalent fractions that are matched up with one another. And if I start in the upper left-hand corner with the blue line, 10 times 27 is represented on one side, and Upper right-hand corner, the green line going down, 18 times 15 is also the same. Now, I can do the math and solve it. Pretty straightforward. 10 times 27 is 270. And if I go through the process, or remember, we can use a calculator in this unit. If I really want to try to get something done a little quicker, multiply 18 times 15 and also find a 270. So we know that those are in balance because those two things are equal. Okay, so that's just where cross multiplication takes us to that little quicker step. Now here's where the algebraic piece of this comes in. Now what happens when we end up with a proportion that is missing a piece, or we're trying to find the missing part of the proportion? The same process will work. We just are having to set up an equation. So here's the equation that they've set up for us. Notice that there are 3 of the 4 pieces that we saw on this last page. We've got the 18 times 15, which we also know at this point to be 270. But now we need to isolate that variable. We need to figure out, how do I get rid of that 10 so that Q stands alone on a side by itself? All right. Well, to do that, I got to do its opposite. Well, what is the opposite of multiplying by 10? I have to divide by 10. And those two things will eventually cancel themselves out, and it'll leave me with Q equaling something. I know that looks like a 9, but that is a Q. Okay. And that means I also, because we are looking for something that is equivalent and equal to, I have to do the same thing to both sides of the equal sign. So if I divide by 10 on one side of the equation, I must also do that on the other side to keep that equation in balance. Okay? So my actual problem here is Q is going to equal 270 divided by 10. Well, that's a pretty easy math problem. Shouldn't need a calculator to realize that Q is going to equal 27 in that case. All right, and if I go back to my other page, we can prove that fact because they show it here in the example problem that they gave us. Q is equaling 27. All right, so let's try one without any help from the book and with some different numbers to see if we can figure this out. And I'm going to then let you kind of solve some things. I'm going to create a second video just kind of going through the answers and walking you very quickly through the process. All right, so let's start in the upper left-hand corner. Multiply this, and I'm just going to write out what it actually is. So it's 8 times 21 on this side, and starting in the upper right-hand corner and coming down here is going to be 14p, or 14 times p. Okay, the next step in my mind is to take 18 times 21 and actually come up with a product for that. So if I go through that process, whether I use a calculator or I don't, I should end up with 168. When I do the multiplication. And now I'm to the part where I need to isolate that variable p by dividing both sides, again treating them equally, dividing both sides by 14 so that I can get these to cancel out, and p will equal whatever 168 divided by 14 is. In this case, if I go through the process, whether it be with a calculator, whether it be just the long division process, I should realize that p equals 12. Now, I can prove that by setting that up in the form of a factor puzzle and determining, does 12 fit where p is, and it does. Okay, that should end up in that same corner and making that a true statement. All right, so I've given you 2 examples here, so you're going to do 3 and 4 on your own. As soon as I show you how we can also use the other example that we've already worked with here, which is, how do I set it up when it is in a ratio format versus a fraction formula, okay, or fraction setup? So now I'm looking here, and I need to realize that these 2 dots also kind of mean the same thing as a fraction bar. So if I want to rewrite it just to make it a little simpler for me, making sure that I've got these things set up in the proper formula, proper way, this is another way to write this ratio proportion that I've got set up here. So if that's the case, what I'm going to do now, another way to do that is to then say 12 times 20 is going to equal 16a. Okay? Now I'm going to come over here and I'm going to multiply 20 and 12 together to realize that I get to 240 is going to equal 16a. Now I need to get a on a side by itself, so I need to do the same thing to both sides of my equation. In this case, it's dividing both by 16, so I can figure out what a will equal. And as I go through that process, Again, calculator, 240 divided by 16, or just going through the long division process, I should figure out that A is going to equal 15. All right? Now I'm going to take it from there and I'm going to put it into an actual factor puzzle so you again can see how even though it's written in a ratio versus a fraction, that I can still set these things up the same way. So here is my factor puzzle. Just to reiterate and bring it all back home again, we've got 16 and 20, and we've got 12, and we're not sure. We're thinking this is 15 down here, but I want to prove that to be true. All right? So as I look at 16 and 12, thinking about the common factors that go into that, I'm going to say that 4 goes into both of them, which they do. Okay, this one is 4 times 4. That makes this a 4 down here. That makes this a 5. That makes this also a 5. 4 times what gets me to 12? That should be a 3. This should also be a 3. So if I multiply the two numbers that are touching that box, I should end up with a 15, and we ended up with a 15. So again, just showing us a way that we can bypass that factor puzzle piece, but we can use the factor puzzle to make sure that I am correct in my answer and how I set that stuff up. All right. One last practice problem, and then I'm going to set you loose on the 4 example problems on your page, which are 3, 4, 7, and 8. So let's set up this next one. Again, for me, I do like setting it up visually so I can see the cross multiplication instead of trying to keep it out of the ratio. It makes it a little easier for me to see where they are set up in this scenario. All right. So my equation itself should be 27b equals 18 times 33. All right. Now, 18 times 33, I don't know that one off the top of my head, so I'm going to go through and I'm going to actually solve 33 times 18. Hopefully do it right. Looks like it should be, oh, there you go, Mr. Mace. Catch yourself in a mistake there. Looks like it should be 594. Yes, 594. So now that means 27b equals 594. All right. Now I've got to isolate that variable. I've got to get the b on a side by itself so I can determine what it is. Treating them equally, I must do divide by both sides 27. So b will equal whatever 594 divided by 27 is. And again, don't know it off the top of my head, so I'm going to go through the process. Now, you guys have the ability to use a calculator. Okay, I'm doing this without a calculator. So I'm going to say that I believe we can get 2 out of there. Should be 54. 5, bring down the 4. Also, again, goes in evenly. Boom. No remainder. So I should at this point realize that b is going to equal 22. Now, I don't have enough time in this video to go through and actually prove the factor puzzle piece. I'm kind of running out of time here. But if I put that into a factor puzzle, this corner, this section B, should be 22. That would be the number that would fill out that factor puzzle correctly. Okay, so remember, cross multiplication is simply the same, trying to find the same answer as we would if we were doing a factor puzzle, but it's going to save us the step of having to draw the puzzle. It's going to save us the step of having to figure out all the factors and go through that process, whereas if I can just realize that I cross multiply, upper left-hand corner to lower right, upper right-hand corner to lower left, put it into the form of an equation, isolate the variable, you're going to end up with your correct answer. All right, so your job before I shoot this next video here is going to be to solve questions 3, 4, 7, and 8. There are 4 questions there for you to solve, and I will create just a really short video to help you check to see if your answers worked, if you got the same answers that I did. All right, good luck, and again, remember, if you have any questions, please ask your teacher.